Welcome to another video. This problem is from the Harvard MIT Mathematical Tournament of 2011. And that's why you see 2011 as an exponent. It's a typical thing that happens. So, for real x, f of x is equal to 1 over the 2011th root of 1 minus x to the 2011. So what we're given is to evaluate 210 applications of f to 2011 and see what happens, all raised to power 2011, and we want to see what the answer is going to look like. This looks very confusing. But one thing about questions like this is, you're not expected to do this 2010 times. What you're supposed to do is, did I say 211? 2011. We're not going to do that. We're not going to apply this 2010 times. We're going to start from the second time because the first time is already given. We're going to do it again and again and again and again. And typically, if this is a competition, by the time you get to the fifth or sixth time, a pattern will already be established. And you can use that pattern to predict what's going to happen when you do it 2010 times. So without wasting any further time, let's get into the video. So let's apply it the second time. We already have the first time. So let's find f of x. Okay. If we do f of x, remember that the input is x, and this is the only thing that happened to x. You raised it to power 2011. So if we're going to do f of x, what we're going to be having is equal to 1 over the 2011th root of 1 minus f of x raised to power 2011. Do you see that? This is the easier way for you to deal with it. And now you could go here and evaluate what this is. So what is f of x raised to power 2011? Let's do that on the side. It means everything here will be raised to power 2011. So let's evaluate that. So we have 1 over the 2011th root of 1 minus x to the 2011 raised to power 2011. So we're evaluating this part. See what happens. This 1 raised to power 2011 is just 1, but the denominator, because of this root, this will cancel this out, and what you have left is just 1 minus x to the 2011. That's the product of that. So we can take this and plug it in here, and what do we have? We're going to have 1 over the 2011th root of 1 minus this, which is 1 over, let's get rid of this, over 1 minus x to the 2011. So this is what you have in here. We can simplify what's in the under the radical sign, which we could actually do this way. Remember, if you collect like terms for this, this is going to be the same thing as 1 over the 2011th root of, this is going to go here. It becomes 1 minus x to the 2011 minus 1 over 1 minus x to the 2011. Okay, now see how this simplifies. 1 minus 1 is going to give you 0. So what you have left is just negative x to the 2011. That's what's going to be left on top. And under, nothing simplifies. But because we have 1 on top of this, you can actually flip what's under and get rid of this 1. It's like saying 1 divided by 1/2. The answer is going to be 2. Because what you're going to do is flip this. So what we have is basically this flipped now becomes the 2011th root of, this goes up now, you have 1 minus x to the 2011, and under it is going to be just negative x to the 2011. And you might wonder, what does this mean? Well, if we apply this radical to the top, nothing gets simplified because of this minus sign. But this one, this radical sign can get rid of this so that what you have left is negative x. And because this power is odd, you can have a negative under the radical sign. So. Okay, so we survived the first steps in the algebra process, and we got this as f of x, which is the second application of f. So we're going to go to the third application now and see what comes out of it. So let's try it. We're going to say that f of x. Okay, now this might get a bit crazy, but just follow, okay? Don't get lost on the way. Now we're gonna have, we're gonna repeat the same thing, but instead of us having f of x here, we're gonna have f of x here, right? So just to save space, or maybe I should write it. I'm gonna write it. So it's gonna be 1 over the same process. 2011th root of 1 minus f of x. Like that, raised to power 2011. And what would this mean? Well, I have to do the math and then I'll write the answer on this side. Okay, so let's do the math. Now, what is this? This is the answer we just got. So I'm going to put it here. Well, let me see what happens if I raise this to power 2011. So let's do that. F of x raised to power 2011 is the same thing as raising this to 2011. That's negative. Let's make this wider. That's right, 2011th root of 1 minus x to the 2011 divided by x. If you raise this to power 2011, because this is an odd exponent, this minus sign is retained. So we're going to have, this is going to be equal to the minus sign stays. This will take this out. So you have just 1 minus x to the 2011, 1 minus x to the 2011 divided by this sign, this raised to power 2011. So that's going to be x to the 2011. Okay, so that's what we're going to get for just this part. Okay, now let's make it more complicated. What if we do 1 minus this? It's going to be 1 minus this. So you have 1 minus f of x to the 2011 will be equal to 1 minus this, which is minus 1 minus x to the 2011 over x to the 2011. Well, minus minus gives us a plus, so I'm going to change this. If you collect like terms, which means you make this also equal to an expression with a base of x to the 2011, I can actually rewrite this one as x to the 2011 over x to the 2011. That's another way to write 1. And now I can deal with the numerator. There's a common denominator, which is x to the 2011. And see what happens here. X to the 2011 plus 1 minus x to the 2011. This is going to take this guy out. The only thing left is 1. So I know that what's inside this radical is 1 over x to the 2011. Right? So I can actually write that expression here because it makes sense. So this is going to be equal to 1 over the 2011th root of this, which is 1 over x to the 2011. Nice. We're almost there. So what happens next? Remember what I said. Well, we can take the root of these, or we can flip what is inside, whatever you want to do first. Well, you can get rid of this one because you can find the reciprocal of what's under the radical. And the 2011th root of 1 is 1. The 2011th root of x to the 2011 is going to be just x. So at the end of the day, this entire picture gives you x. If you see it, you got good eyes. If you don't see it, look at it. Okay, so this is going to make this become x, and this stays as 1. So 1 over x is going to give you just x, okay? So, and that's it. So do you notice that within 3 iterations of f being applied, we have come to the beginning? So when you do it the first time, you're going to get this expression. When you do it the second time, you're going to get this expression. When you do it the third time, you're going to go back to x. And this is the simplified form. This is the easiest part. Because when you start from this again, you do f of x, you're going to get this. You do it again. So by the time you do the 4th iteration, the 4th application of f, you're going to go back to f of x. So it means that f of f of f of f of x. How many times? Yes, this is the same thing as f of x. But if you do it just 3 times, you're going to get x. So you go back to the question, how many times do they want me to do it? Well, they want me to do it 2010 times. Well, this is not the best one. This is the easiest one. So this, every 3 times you apply f, every 3 applications of f leads you back to just x. So how many 3-time applications are in 2010? How many? Well, is it a whole number, or will there be a remainder? Well, we know that 3 divides 2010 because the sum of the digits is divisible by 3, right? Just perfect. So I'm going to get rid of this. So 2010 applications of f to x has the same effect as not applying any f to x, since 3 divides 2010. Okay, that's the justification. Maybe there's a better way to state this, but that's the idea. So we can say that, therefore, f of the way we wrote it originally, this way, tap, 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 then we have f of 2010, then we go 1, 2, 3, 1, 2, 3. Let's do this. 2010 applications is equal to f of f of f of 2010. Oh, by the way, what I want to do is, I want to raise this to power, according to the question, 2011, okay, is the same thing as this raised to power 2011. Okay, but we know it's the same thing as just this 2010. It's the same thing as not applying any f to x. So this is the same thing as 2010 raised to power 2011. Oh, it's 2011 that's inside, not 2010. Oh, it's 2011. Let's go. 2011. 2011. And that's our answer. Okay, I don't know why I put parentheses around it. No parentheses. So the hardest part of this is just the algebra and you having faith to predict that when you do some applications of f to x, you're going to end up with something you can relate with, and then you can predict what's going to happen in the future. Never stop learning. Those who stop learning, stop living. Bye-bye.